So here normal contact, the weight mg. What are other forces that are acting? This is what is the maximum angular speed of the platform for which no slipping occurs. So here there will be a friction. Shall I put limiting friction and pseudo force, or say better call centrifugal force? M omega square into this one, the normal reaction. So what is N? N minus mg co 0. What is the limiting friction? Mu s into N. It's a rough platform. So what is FL is equal to mu s mg. So let's write equation. FL minus m omega square r. So this is mu s mg. If the angular velocity of the platform is greater than this, slipping occurs. As long as the angular velocity is less than omega max, slipping will not occur. Okay, now you see that why we are bringing centrifugal force. You can directly ask, sir, why you brought it? So let me make omega greater than omega max. I'll bring the situation. What is the friction? Nature of friction will be static, no? If omega greater than omega max, what about the friction? I'll write it here. Omega less than or equal to omega max, the friction acting will be static and block moves in circular path. If omega greater than omega max, what about the friction acting will be? Limiting friction or kinetic, better you write it. How the block will move? Block moves in circular path for whom? Block moves in circular path. I think I have to write all the conditions. Block moves in circular path for A and at rest for B. Now, omega greater than omega max. Tell me what conditions you are going to write it. This will be very interesting. So why we are bringing this concepts is what you can understand. Block for person B, how do it move? Red color we took him, no? Yeah. Yes, anybody? The very best thing is what I'm asking here, no? For person A, how the block will move? Direction of omega. Yeah. I think I'll change omega. Okay, no, yeah, fine. Now look at this. When omega greater than omega max, for person B, block moves radially outward, radially outward for person B. For person A, some spiral path, no? Some spiral path, it will not be in circular path here. Person A says not in circular path. It will leave circular path. Person A what it says? Block leaves circular path for person A. These comments are really very important for these two conditions. Okay, got this one. I think it will be very difficult to analyze in the ground frame, no? Why to use circular path? You will not say that friction not sufficient to provide required centripetal force. That's why it will use circular path. Person B it tells very clearly the centrifugal force was greater than the limiting friction. That's why the block moved away. Person A, what happened for person A? The friction not sufficient to provide required centripetal force, and it will leave circular path. So how do it move? It will try to move like this. So these are the things what we do come across. So in which frame the numerical will become very easy? Definitely in the disk frame, no? In the rotating frame. So when the centrifugal force will come into picture, whenever you are doing problem in the rotating frame, centrifugal force will come into picture. Otherwise, you are doing in the ground frame, no need to go for centrifugal force. Centrifugal force frictions are FL is centripetal, FL is centripetal, this is centrifugal. There's a stupid idea where in some other subjects you might have learned. Don't bring that in physics. That's all. I'm making clear. This is centrifugal. What is the friction? Friction balances centrifugal. That's all here. So centrifugal when will come? When you are describing motion with respect to rotating. When centripetal will come? No, in the ground frame, what will happen? The friction will become, friction will provide required centripetal force. You should not show this m omega square r when you are doing problem with respect to ground frame. Next, regarding centrifugal force, there are, let me introduce to the cases also. There's a platform. It is rotating with an angular velocity.